Hey, good morning, everybody. Well, another great week here. It was cold, but at least we were inside and we could do algebra. Kids were excited about that. So this week, as you know from my email last week, we focused on solving algebraic equations. We took what we did in our previous unit on algebraic expressions, and we now started to use that information to help us solve algebraic equations. So I want to show you what we focused on this week. So we started this week looking at a model. And the focus here was, what does it mean to be equal or balanced? And so we used the analogy of a balance scale. And so on this balance scale, we had two rectangles and we had squares on each side. And the question that I posed to students was, what would balance one rectangle? So if I just had one rectangle on the side, based on this information, what on the other side would balance it? And so the cool thing about this is it really brings out students' algebraic thinking naturally. They have this within them, and they do this process without even thinking about numbers and math. So for example, in this situation, a student would say, well, I noticed that we have two squares here, so if I remove two squares, and I remove two squares over here, it will remain balanced because each of those squares is equivalent. Or if you want to relate it to weight, they have the same weight. So now I end up with a situation that looks like this. So I removed my two squares from each side, still balanced, and now I have two rectangles and I have four squares. And students, again, notice that, well, if I look at this, I can divide these two rectangles into these four squares, or I should say these four squares divided by these two rectangles. Now, if you hear the language that I'm using, that I'm repeating what students used, they're really using math language, again, naturally. So they simply came up with, in the end of this, if I divide these up, so if I kind of line up, I'm going to have two squares with this guy and two squares with this rectangle. So in the end, my answer would be two squares would balance one rectangle. So that was the beginning of the week. And then we took this and we took this model and we said, okay, now let's translate this. Let's translate this model. So if I told you that one rectangle equals an x, so a variable, and one square equals 1, so the value 1, could you translate this model into math, or as I like to call it, Mathlish, okay, from English to Mathlish. So we're going to translate this model into math, which in this case is going to produce an algebraic equation. So here I'm going to have 2, so there are my two squares, each of these are 1, plus I have my two rectangles, which each of those equals an x, so we have two x's. And because this balance is balanced, I can say that this side equals this side. And again, that symbol right there, that equal sign, is really a key concept for students to understand, that concept of a balance which produces an equation. Okay, so over here then, I come over here and I notice I have 1, 2, 3, 4, 5, 6, 6 squares. So I now have this equation. So then I asked students to review because we took notes on that when we originally manipulated that model. They took notes on what they did so that they could come back to this and remember. And I asked them, okay, so what did we do first? Well, students immediately remembered, okay, our first step was we removed two squares from each side. And so I said to them, well, how would you translate that mathematically? And they immediately knew, well, this is what we do. To remove something means that we are subtracting it. And we did it to both sides. And I asked students, well, why did we do it to both sides? Why was that important? And again, they knew, well, if I don't do it to both sides, it's no longer going to be balanced or equal. And so that, again, is the key concept. Notice I showed it on both sides. And again, this is something that you will see over and over and over in every equation. So now I said, oh, what is left? What's remaining in my equation? And so we can see, well, we still have our two x's. Okay, so notice I brought that down. Notice 2 minus 2 is 0, so those are gone. Over here, after I remove two squares, I'm left with 4. So now I have the equation 2x equals 4. And then, again, I asked them, well, what was the next step? So they looked at their notes and they said, well, remember we took these four squares and we divided it by these two rectangles. Well, here's dividing by those two rectangles. Here's my four squares divided by those two rectangles. Okay, and in the end, we came up with an answer of, as I showed before, get rid of those two, we came up with an answer of x equals 2. And we can see it right here. We proved it on our model. We proved it algebraically. And again, this is getting kids to understand what that concept of balance and what it means to actually solve an equation really is. So from there, what we just did is we solved what is called a two-step algebraic equation. Notice that we had to perform 2 steps. So here would be step number 1, and here would be step number 2. So we performed 2 steps. Well, I told them I'm going to push them further, okay? Because I know what's coming next year and beyond, and because they are in an enriched math class, I want them to be able to solve multi-step algebraic equations, not just 2-step. And actually, in the model that you're going to see next, without even knowing that this was a multi-step equation, again, students' natural algebraic thinking came out and they already proved they could solve it, which is kind of cool. So in this model, okay, so notice we got a new model. So I first asked them, what's different about this model? And immediately they noticed, oh, I have rectangles on both sides of the equation now. And I said, okay, so now, again, the question is still the same. What will balance one rectangle? And again, I gave students time to manipulate and figure out and take notes on what they did, the steps they took to balance out one rectangle. So again, we had a student that said, well, I'm going to remove, I think I can remove 3 squares. If I remove these 3 squares, then I have to remove 3 squares over here as well. Oh, come on. There's 2 and there's 3. Okay, again, knowing that each of the squares weighs the same, as long as I take the same amount on both sides, I remain balanced. I remain equal. So now we have this situation. So a student said, well, each of these rectangles should have the same weight. So if I remove this rectangle, as long as I remove this rectangle, again, they should remain balanced. So now I have this situation. And immediately students remembered in our previous problem, well, this is very similar. Now we have 2 rectangles and we have 4 squares. So I'm going to divide these 4 squares between 2 rectangles. And I'm going to end up with, again, the same situation that I had before. So again, students didn't realize yet that they really solved a complicated multi-step algebraic equation that they're going to do a lot next year in pre-algebra and even beyond that in Algebra 1 in high school. And so, again, we came back to this problem and I said, okay, now let's translate this. If again the rectangle equals 1 and equals x and a square equals 1, let's translate this equation. So again, over here I have my 3 squares, and again each one of those is worth 1, so there's my 3, plus each one of these rectangles is an x, so I have 3x, and again because it is balanced, I can see it's balanced, I can say that it's equal, and over here I have my 6 squares. Again, actually, I don't have 6 squares. I believe I have more than that this time. What do I have here? I have 7 squares, okay? And I have my 1 rectangle. So there's my equation. Now, if I gave students an equation that looks like this, initially without the model, again, because of the way our brains work, a lot of students are going to get confused immediately. But I reminded them, we've already solved this. You've already proven that you can solve this. So I said, let's go back to our notes and let's look at what did we do. So again, students went back to their notes and they remembered, oh yeah, first thing we did is we removed 3 squares from both sides. So again, the question is, well, what does that look like in math? Translate that to Mathlish. So here is removing 3 squares from both sides. It means we're subtracting 3. And now I can see what's remaining. So I have my 3x's equals, over here, I have now 7 minus 3, I have 4 squares and I can see them. But I still have that 1x. Now this is a review of our previous unit when we were solving or simplifying algebraic expressions. Over here, the temptation is, can I add these two together, this 4 plus 1x? Well, in this case, you can see that I can't, right? They're 2 different things. We call them, they're not like terms. This one has an x. This 4 doesn't have an x. They're not alike. Okay, so up here, we can visibly see it, that they're not alike. I can't combine them. So I can't do that. So now again, we go back to what did we do with the model? Well, remember that student said, hey, I'm going to remove 1 rectangle from each side. And as long as I do it to both sides, I remain balanced, I can do that. So what does that mean in math? Here's what we just did. We took away 1 rectangle, or 1x. and I did it to both sides. So now, extend this up here. So now we're left with, let me clear some space here. Get rid of some of these guys here. Okay, so now we're left with, again, we can see in the model, I have 3x minus 1x, I'm left with 2x. And over here, I'm left with just my 4 squares. And leads to the last step. What did we do finally? We said, well, we're going to divide these 4 squares by these 2 rectangles. So I can see that 2 squares are going to balance out each of those rectangles. Well, what does that look like in math? I'm going to use the fraction bar as my division sign. I'm dividing by those 2 rectangles. And x equals 2. And I can see it once I get rid of this and my 2 squares, I can visibly see there's my 1 rectangle equaling my 2 squares. So again, this model, this idea of balance, using these squares and rectangles really gives kids a concrete way of understanding algebra. And so that was our Monday, Tuesday. From there on, it was now full-on solving multi-step algebra equations that look like this, where we had variables on both sides, or they could have been 2-step equations like we did in the previous problem. So we're going to keep working on this. We're going to keep building on this. Next week, we might get into a little bit of problem solving, where now students are reading a problem and now coming up with the equation and solving it. So hope you guys are having a great weekend, and look forward to another great week. See ya.